Hello there, it's Luke, and here I am. And in this tutorial, we're going to be discussing blood flow through the kidney. And this is really to sort of set us up for then going on to discuss the renin, angiotensin, and aldosterone system, which helps to maintain blood pressure. Okay, so first slide, here we go. So very briefly, we'll discuss the functions of the kidney. So obviously, the kidney is really crucial for excreting waste products from the body, for maintaining a balance of ions. So those are those charged particles, things like sodium, potassium, and calcium, that are absolutely vital for the working of our for our heart muscle, our muscles globally, our nerves, and all these things, to stabilize the pH, so the acidity of the blood, so that the enzymes within the various tissues work well, conserve the nutrients that we need, so things like glucose and proteins and all the things that we need to have energy, and also to sort of repair our tissues. And finally, and sort of most importantly for this particular topic, we're going to be thinking about how it regulates the blood volume and blood pressure. Okay, and it does that by sort of adjusting the water that is excreted, and also by interacting with other organs and tissues within the body by releasing hormones, principally sort of renin and aldosterone, but we'll get to that in another tutorial. Okay, so the kidneys have a sort of vested interest in maintaining cardiac output and blood pressure, because they receive, and they need to receive, about a quarter of the blood supply, so about 25% of the cardiac output every minute, in order to perform those functions that we just highlighted. Now, I really like this diagram of the kidney. There's obviously, you'll have no doubt seen many more complicated diagrams, but very briefly, the blood enters from the arterial end of the systemic circulation. Here's my little pointer. Enters through the afferent arteriole, where it either heads into the glomerular capillaries, whereby some of the fluid is filtered into the Bowman's capsule and through into the sort of through the lumen of the nephron, and eventually excreted as sort of water and waste products, and urine essentially, and some of the flow from the systemic arterial end of the circulation will pass not into the capillaries within the glomerulus, but will travel out of the afferent arteriole, and these sort of capillaries sort of wrap around, if you like, the nephron, so that there can be movement of various solutes and water, so that we reabsorb all the things that we still need, and secrete and leave in the sort of lumen of the nephron anything that we no longer need, any sort of excess fluid and solutes, for instance. Now we're going to zoom in a little bit, and this is really where the nephron is able to auto-regulate, so it can manage the flow of blood through the capillary bed within the glomerulus and through the capillaries that sort of wrap around the nephron, that are engaged in that movement of solutes and water back and forth. And I've done a sort of PowerPoint diagram that I'm sure you'll enjoy just here, to explain exactly how that works. So in a situation where we've got a good sort of highish blood pressure, you'll see that both the afferent and the efferent arterioles are dilated, and there's a good flow of blood both into the efferent arteriole, but also, importantly, into the glomerular capillaries, and then from there you get that glomerular filtration of fluid into the lumen rather of the nephron. Now, in a situation where the systemic blood pressure drops, we can see that if the afferent and efferent arterioles remain dilated, then we still have a great deal of fluid that's being filtered out and potentially sort of lost from the circulation, and we may have a situation where actually we're excreting far too much fluid, and that will again impact on the venous return back to the heart and consequently affect the cardiac output and the blood pressure. So what can happen is that we can constrict the afferent arteriole at the sort of entrance to the nephron, if you like, and this reduces both the blood flow into the efferent arteriole and, crucially, into the glomerulus, which will consequently reduce the glomerular filtration rate. Now, that may reduce the GFR, the glomerular filtration rate, to such a point where the kidney doesn't function efficiently, and it doesn't do those functions that we discussed in that first slide. And so the sort of small adaptation that can be made is that the efferent arteriole can also constrict, and so you've got that resistance to flow on the other side of the glomerulus, and so it's the flow is actually improved through the glomerular capillaries, and so we maintain the sort of filtration of fluid through the glomerulus and into the lumen of the nephron, and so in this situation, this is how the GFR is maintained. However, there comes a point, and it's probably below about 75-ish mean arterial blood pressure, where it doesn't matter how much the afferent and efferent arterioles constrict, they can't maintain the flow of blood and filtrate through the nephron, and so we tend to see a drop off in both the function of the kidney, but also the blood supply to the sort of through the kidney, if you like, as well, which again will impact on its function. And here we are. Here's a quick recap of those functions, and these are the sort of things that will be affected. And in somebody with a sort of failing or injured kidney, we very quickly will see an elevation in potassium, for instance, and also a drop in the pH, so the blood becoming more acidic as the sort of renal injury gets worse. Now, as we'll recall from previous sessions, we have many mechanisms available both to the body itself in health and also to clinicians to sort of engineer an improved cardiac output and blood pressure. And so any changes that we can make to contractility and preload, which make up the stroke volume, or making the heart rate go faster, or tightening up the sort of vasoconstricting the vessels within the systemic circulation, will hopefully improve that blood pressure and then sort of maintain the flow of blood and filtrate within the nephron. And it's at that point that we'll sort of move on to the renin-angiotensin aldosterone system in forthcoming tutorials. But in summary, the kidneys receive about 25% of your cardiac output, and blood flow and glomerular filtration rate is maintained by constriction and dilatation of the afferent and efferent arterioles leading into and out of the glomerulus respectively. However, that only works to a point, and so when the mean arterial blood pressure drops below about 75 millimeters of mercury, then that autoregulation cannot maintain the flow of fluid through the glomerulus, and so we tend to see an impact upon our renal function. Thank you very much for listening.